Every single scar you see on the moon is a record of violence. Billions of rocks, traveling at 40,000 miles per hour, hitting a dead world with nowhere to hide. Now here's the question nobody asks out loud. Earth is right next door, same neighborhood, billions of years of history. So why doesn't our planet look like that? The answer isn't what most people think, and once you understand it, you'll never look at either world the same way again. To understand why the moon is shattered and Earth isn't, we have to go back, way back. 4.5 billion years ago, our solar system wasn't the clean, organized place it is today. It was a demolition derby. Billions of rocks, boulders, protoplanets, all competing for the same orbits, crashing, merging, destroying each other in a cascade of collisions. Both Earth and the moon were in this midst of this chaos. They received the same demolition, the same relentless bombardment that lasted, not years, not centuries, but hundreds of millions of years. Scientists call the peak of this violence the Late Heavy Bombardment. Both the Earth and the moon took the hits, but what happened after impact was completely different. And that difference? That's the entire story. The moon is geologically dead. It has been, essentially, for about 3 billion years. No active volcanoes. No tectonic plates grinding against each other. No rivers cutting valleys. No wind. No rain. Nothing. When a rock hits the moon, the crater it carves just stays there. There is no erosion. No geological process to fill it in. No atmosphere to slow incoming objects and burn them up. A crater made 4 billion years ago looks almost identical today as it did the moment it formed. The moon is, in a very real sense, a museum of the solar system's most violent era. Every scar you see is a timestamp. Some of those craters are enormous. Mare Imbrium, the large dark patch you can see on the moon with the naked eye, is the scar of an asteroid roughly 200 kilometers wide. The force of that impact was so staggering it created mountain ranges thousands of meters tall around its rim. And billions of years later, it's still there, perfectly preserved. But wait, stop. Because here's a fact that should bother you. Earth is bigger than the moon. A bigger target. More gravity pulling things in. By every reasonable calculation, Earth should have more craters than the moon. Not fewer. So what's going on? Earth has something the moon completely lacks. 4 somethings, actually. 4 planetary defense systems, all working simultaneously, that have been erasing our crater record for billions of years. Defense system number 1, the atmosphere. Every single day, roughly 100 tons of space material enters Earth's atmosphere. Most of it never reaches the ground. Our atmosphere, a layer of gas only about 100 kilometers thick, acts as a continuous shredder. Rocks slam into air molecules at hypersonic speeds, compress the air in front of them faster than it can move out of the way, and the resulting heat vaporizes them. The moon has no atmosphere. Not even a trace. Every rock that comes its way hits the surface at full, undiminished velocity. Defense system number 2, plate tectonics. Earth's surface is not one solid shell. It's more like a cracked eggshell floating on a mantle of slowly churning rock. These plates are constantly moving, and where they collide or diverge, the ancient surface gets recycled. Oceanic crust, which covers 70% of Earth's surface, is destroyed and recreated on a timescale of roughly 200 million years. Any crater on the seafloor? Gone. Subducted, melted back into the mantle and reborn as fresh crust elsewhere. Defense system number 3, erosion. Water, wind, ice. Over millions of years, these forces sandpaper the landscape into submission. A crater that forms on a continent gets attacked immediately. Rain fills it, rivers cut through its rim, glaciers grind it down, wind slowly carries the evidence away grain by grain. Give it 50 million years. And even a scar left by a city-sized asteroid starts to blur. Give it 500 million years, and it nearly disappears entirely. Defense system number 4, volcanism. Earth's interior is still hot. Radically, violently hot. Volcanic activity, especially over the deep past, has repeatedly repaved enormous sections of our surface with fresh lava. The evidence? Buried under kilometers of new rock. The moon's volcanic activity largely ended around 3 billion years ago. Earth's? Still going. Think about what this means. The moon shows you the raw, unfiltered history of the solar system. Earth actively hides it. Our planet isn't less bombarded. It's just a far better housekeeper. Earth does have craters, of course. We found roughly 190 confirmed impact structures around the world. Meteor Crater in Arizona is one of the youngest and best preserved, just 50,000 years old, about 1.2 kilometers across. It looks the way it does because it's so young. Earth hasn't had time to erase it yet. But the most important craters on Earth, you can't see it all. Chicxulub, the impact that ended the age of the dinosaurs 66 million years ago, left a crater roughly 180 kilometers across. Today it's buried under a kilometer of sediment and partially beneath the Gulf of Mexico. We only confirmed its existence in the 1990s. The crater is still there, perfectly preserved, underground, erased from the surface, but waiting, patient, to be found by scientists drilling deep enough to hear the echo of that ancient catastrophe. This is the pattern everywhere on Earth. The evidence survives, just hidden beneath everything our planet has piled on top of it. And here's the thing about all of this. Every force that hides our craters, the atmosphere, the tectonics, the water, the volcanoes, is also what makes this planet alive. The moon is a perfect record of destruction. Earth is a perfect record of survival. If you find yourself actually stopping to think about our planet differently right now, you're going to love what we explore every week on this channel. Hit subscribe, because the next time we look up at the night sky, you're going to want the context. Here's what makes Earth genuinely unusual. Look across our solar system at the rocky worlds. Mercury, completely covered in craters. Mars, ancient highlands, absolutely hammered. Our moon, the museum we've been discussing. Earth, comparatively clean. Mars is fascinating, because it's the middle case. Mars had some geological activity. Some ancient volcanism. A thin atmosphere. It has fewer craters than the moon, but far more than Earth. Mars is what happens when a planet's defense systems partially work, then shut down. Its geological engine cooled. Its magnetic field collapsed. Its atmosphere was stripped away by solar wind. And the craters started piling up again. And this brings us to the real reason Earth is different. It's not luck. It's heat. Earth has an extraordinarily large iron core, the legacy of a planet-scale collision early in its history. That core generates the heat that drives our tectonic plates. The tectonic plates drive our volcanic activity. Our geological activity maintains our magnetic field, which protects our atmosphere. And our atmosphere burns up incoming impactors. It's one interconnected machine. And it's been running for billions of years. The next time you look at the moon on a clear night, you're not looking at a damaged world. You're looking at a witness. Every crater up there is a rock that hit our neighborhood. That crossed through the same space Earth occupies. Some of those rocks hit us too. We just cleaned up the evidence. The moon preserved the record. Earth rewrote it. And the reason we're here, asking these questions, looking up at that battered gray surface from a living green world, is precisely because our planet never stopped fighting to stay alive. That's the real reason the moon is covered in craters. And why, against all odds, we aren't. We've covered a lot of ground today, from the early days of our solar system, to the four invisible forces that have been quietly erasing Earth's impact record for billions of years. The moon bears every scar it's ever received. Earth heals, recycles, and buries the evidence. Not because our planet was hit less, but because it never stopped working. Thank you for watching. If this gave you a new way of looking up at the night sky, consider subscribing. There's a lot more where this came from. We'll see you next time.